All right, welcome back to Mr. P Helps with Calculus. This is Unit 3, Day 8. Now we're going to be exploring differentiation with exponential and logarithmic functions. It's really just formulas you're just going to have memorized. And once again, kind of like the inverse sine and inverse tangent equations, it's something that you don't use a whole lot, something you definitely want to be studying at the end of the year as well as right now as you're working on Unit 3. All right, so that's something that's covered in the last video. Derivatives of exponential and logarithmic functions. So this is the formula. It's really just memorization. To find the derivative of any exponential function, so you're going to take the function itself, whatever the number a is, whatever the number u is, so itself times natural log of the base, so natural log of this, or log base e of that, and multiply that by the derivative of u, whatever that number is. And it's really just the same formula. All right, so we got three parts here. We've got itself, so 2 to the t minus 3. 2 to the t minus 3 is missing here. So it should be 2 to the t minus 3. Then multiply that by 2 to the t minus 3 times natural log of base 2. Oh, it's two different parts. Oh my gosh, folks. All right, let's get rid of that. I should have known there wasn't a mistake there. Sorry, it's sum and difference rule. It's two different parts. We're going to do differentiation of just this part first. So 2 to the t times natural log of 2 times the derivative of t, which is 1. And then differentiate the minus 3 to 0, and boom, there's your answer, which is just all of this. You don't need the 1 or the plus 0. All right, over here, we've got itself, copy it, times natural log of the base, times the derivative of the exponent. And then it's just a matter of simplifying it down. All right, so these are done just the same. So it's itself, 8 to the power of all that, times natural log of 8, because that's the base, times the derivative of all of this, which gives us 4x cubed. You know, it's simple power rule. You should already know that by now pretty quickly. By now, you should be able to do those very, very, very quickly. And then it's just a matter of cleaning up to make it look presentable. It really doesn't matter what order this is. It could be a multiple choice question where you never know what you're going to get. It's all multiplied this times this times this. You could rearrange the orders in any way you want to match whatever the multiple choice answer is. All right, so it's itself times natural log of the base times the derivative of cosine of x, which is negative sine of x. Pretty straightforward there. There could be some chain rule here, but there isn't because it's just an x. But you always got to be ready for that. All right, now we've got derivative of a logarithmic function. Once again, just need to memorize this. So log base a of u. A could be any number, u could be any number. So it's always going to be 1 over the argument times natural log of the a, the base, multiply that by the chain rule, basically. Multiply that by the derivative of whatever the argument is. All right, so it's 1 over u, which is the argument. So it's 1 over the argument times natural log of the base times the derivative of the argument. And then you could clean this up to this, because most likely this is what a multiple choice solution would look like. All right, remember, log is log base 10. So remember, if it's just log, it's always log base 10. So it's 1 over the argument times natural log of 10, which e, remember, doesn't go into 10. If it was log of 10, it'd be 1, but not natural log of 10. Cannot be simplified. So it's then multiply that by the chain by the derivative of the argument. Derivative of sine of x is cosine of x. And then it's just a matter of simplifying. You'll see that I got a little bit slick with simplifying it because sine over cosine could just be turned into, cosine over sine could be turned into cotangent. So these are just ways of simplifying. And then it's 1 over natural log of 10. So it's just cotangent of x over natural log of 10. But you never know what multiple choice is going to give you. All right, so same thing. 1 over the argument multiplied by natural log of the base times the derivative of the argument, which is just 8. And then it's just a matter of simplifying. Now, this question, I'll be honest, I did this a little bit more work than probably need to be done. I exponentiated both sides, but you really should know back from pre-cal that log base of 4, anytime these two match, they're inverses of each other. Logs are inverses of exponentials. So if these two numbers match, these two just cancel each other out, to be honest. And you're left with just cosine of x. Now, how did I do it? Because I did it a little bit differently. I exponentiated. I raised each of these to raise the base power of 4. 4 to the log base power of log base 4 and 4 to the power of log base 4 cancel each other out, so you're left with just 4 to the power of x. Both of them, well, if they both have the same base, then their exponents must also be equal to each other. Essentially, in the end, I'm doing the same steps with just a little bit more work. And you're going to get the exact same answer. So if this is the original function, then the derivative of that would be negative sine of x. So all I did really here was simplify it. And once I've got it simplified, because this is essentially just cosine of x, then it's real easy because I have that memorized. And that's going to be it. Pretty short video. Thanks again for watching, and I'll see you on the next one. Remember, these are rules. You should have a cheat sheet. I know I said this in a prior video, but I'm going to say it again. At the end of the year, you need to have a cheat sheet, front and back, one sheet of like all the formulas, and it would have to be written pretty small because there's a lot of them. If you look online, you can see lots of different cheat sheets that people have used of all the formulas you have to have memorized. These are ones that you forget by the end of the year. Thanks again for watching. I'll see you on the next